Welcome, Calculus BC. This is lesson 4.1, U Substitution, which is the reverse chain rule. Let's begin. All right, let's differentiate this using the chain rule. So it's going to be 4 times 1 plus 5x to the third power times 5, derivative of the inside. This one would be cosine of 1 plus 5x times the derivative of the inside, 5. All right, now let's integrate these problems that are very similar. Look at number 4. This is like the derivative of number 2. So if I went backwards, I should go to sine of 1 plus 5x and then plus some c, because you got to do that for integration. And you can always check that by deriving this, and you'd get to this answer. Now, let's look at this answer right here. It's sort of like this one, but I have an extra 4 here. So I know I have to do some sort of pattern like that. And I see there's some pattern going on here, but I can't just say it equals straight up this or straight up this. I'm going to have to do something else to it. And what happens is I have to say, well, this is going to actually equal 1/4 times 1 plus 5x to the 4th plus c. Now, we solve these things basically using something called U substitution. So here's how U substitution works. So you set U, which is like an x, but a different variable, to what I'm going to call the inside function. So you have to set a u, and it's usually what's inside. Just like with chain rule, you're always looking for what's inside. And then you find du just by deriving your u, and then you substitute in your u. So you're getting rid of the x's in the integration and turning them into u's. And they're supposed to be in a form that you are more familiar with, so then you can integrate it using your rules that you know. And then after you integrate, you sub back in the x's for the u's, because you want to end with x's. So here's an example. Say you see this one 3. My u is a good guess for the u is whatever's inside. So I'm going to set my u to be 1 plus 5x. Now derivative of u, which is du, would be just 5, and we say 5 dx, because we're differentiating with respect to x right here. So 5 dx. And what's cool is you substitute in. So instead of u, 1 plus 5x cubed, that whole thing's going to be u. So I'm going to set my integral to be u cubed. And then the du can substitute in for the 5 dx. Like those two things combine their powers to a du. So now my integral is u cubed du, which is just power rule. So that's going to equal u to the 4th over 4 plus c. And I can substitute my u back in, get my x's. So my final answer is 1 plus 5x to the 4th power over 4 plus c. Cool. And you can always double check this by deriving this. I mean, if you derived this answer, you would get the c would cancel out and this 4 would come out. And you'd end up getting back where you started with, because of chain rule. Number 4. So my inside, I'm going to say my u is the 1 plus 5x. So u is 1 plus 5x. That would make my du 5 dx. You should always have a dx with the du's. So this is my u. So it's going to be the integral of cosine of u. And the 5 dx is my du. So cosine of u du. So antiderivative of cosine is positive sine of u plus c. Substituting that u in, you're going to get sine of 1 plus 5x plus c. Cool. All right, let's do some harder ones. So sometimes they don't work out as nice as those problems. We got to do a little bit of work. Let's try this one. So, I mean, you could expand this 10 times and get the answer, but that's crazy. So let's do U substitution. U equals 3x minus 1. And du is going to be 3 dx. I have a problem. Don't have a 3. Okay, I can substitute this in for my u and get the integral of u to the 10th power. But I just have dx. I don't have 3 dx. So guess what? I'm just going to put a 3x here. That's like multiplying by 3x. So to multiply by 3x, I must also do the opposite, divide by 3x. They cancel each other out to 1. So now this 3 dx can become my du, but I still have this 1/3 on the outside. Got to keep that. All right, so u to the 10th is going to be u to the 11th over 11 plus c. Make sure it's 1/3 times that. And then substitute that u back in. You're going to get 1/3 times, we can combine this. Let's not be lazy. So it'll be 3x minus 1 to the 11th over 3 times 1 is 30. 11 is 33 plus c. And there's an answer. Okay? Let's get a little weirder. Okay, this one. Now, if you have a square root, what's in the square root is probably your u. So let's go with that. For x cubed minus 5. And your so du is going to be 12x squared dx. Okay, so I know this thingy is my u. So the integral of square root of u. But I have 6x squared, and I want 12. So I have to multiply that 6 times 2. So 2 times 6, which is 12. But if you multiply by 2, you must also divide by 2. So then this whole thing can turn into my du. So I'll just leave a 1 on top over du. And it's like this. All right, we can integrate that. Now, square root's kind of weird, but I can bring it to the top. I'm going to rewrite it as the integral of u to the negative 1/2 power. And then I will integrate that. So u to the, add 1 to it, positive 1/2 power. And then you divide, well, you multiply by the new reciprocal, so 2 over 1. Same thing as dividing by 1/2 plus c. And don't forget this 1/2 that came down. Guess what? They canceled out. So it's u to the 1/2 power plus c, which means my answer is going to be 4x cubed minus 5 to the 1/2 power plus c. You could make a square root, but Try this one. Okay, remember when I say sine squared of x, this is like saying sine of x squared times a cosine. So let's try, maybe you say the cosine's the u the first time, but if you do this, you're going to have a problem. You want to have the 1 inside the square. So I'm going to say my u is sine of x, and du is cosine of x, dx. So, hey, that's a good du. And then the sine is your u, so it becomes the integral of u squared du, which is just going to be u cubed over 3 plus c, which is sine cubed of x over 3 plus c. All right, let's try something weirder. So sometimes it's u sub, but you got to rearrange things because like just doing u sub didn't get rid of all the x's. So let's say this. Okay, so I would say, okay, that's probably my u. So x plus 1, x minus 1. Usually this happens with square roots. And then derivative of that is just going to be just 1 times dx. But that, okay, this is a dx. Cool. So that's our du, and inside here is u. But this doesn't get rid of this x. But what I can do is I can take this u equation. I'm going to rewrite this whole thing. Add 1 to both sides, and I can say u plus 1 equals x. So then I can just substitute u plus 1 over here and watch the magic happen. This becomes u plus 1 times the square root of u, du. All right, and that's still weird to integrate, but you can actually distribute that square root to both sides. So you're going to get the integral. Now this is like u to the 1 times u to the 1/2, which is u to the 3/2. Think about that. Plus, I'm going to say u to the 1/2. I don't want to leave it square root right now. Du. All right, integrate both of those. So the first one becomes u to the 5/2 times the reciprocal 2/5. It's like dividing by 5/2. Plus u to the 3/2 times the reciprocal 2/3 plus c. And then you can just substitute your u's back in. So my answer is 2 times x minus 1 to the 5/2 over 5 plus 2 times u, nope, not u, silly Billy, x minus 1 to the 3/2 over 3 plus c. Oh, we're done. Bye.